Hey everyone, it's Alice from Top Mark Science here, and today we're going to be exploring atoms. By the end of this video, we aim to achieve the following objectives so that you can identify the key structures of an atom, distinguish the key differences between subatomic particles, and draw different atoms depending on the number of electrons in an atom. Hopefully by the end, we can all be in the green. Let's get started with some stuff that you might already be familiar with. Everything around you is made of matter, in other words, stuff. Pause the video here and see if you can guess what stuff these pictures might be representing. Well done for having a go, guys. We have gold, helium, carbon, oxygen, but some things are made of more stuff. For example, water is H2O, made of hydrogen and oxygen. These are all examples of atoms. Atoms have a basic structure, which we'll go through now. They have a nucleus in the middle, which contains protons and neutrons. Around the outside, we have tiny particles called electrons, which orbit around the nucleus, in things called shells. They can also be called orbitals or energy levels. These are the subatomic particles. You can remember them by P, E, N. N. You might be wondering what this stuff is in between the shells. There's not much there because it's completely empty space and makes up the majority of an atom. It's your turn now for a little practice. Pause the video here and name structures A to D. You can use the words in the box on the left. If you finish before everyone else, have a go at the challenge. Let's see how we all got on. Get your marking pens at the ready. A is the shell. Give yourself a tick if you got this correct. If you didn't, don't worry. This is just a bit of practice. Annotate your work so you know for next time. B is our electrons. C is empty space. And D is the nucleus. If you got onto the challenge, the red and blue spots are protons and neutrons. Well done, guys. Excellent start. Now let's take a closer look at these subatomic particles because they all have properties that make them special. They also help keep the atom together. You may have heard of the term opposites attract. Well, it's just that. It's this feature that helps keep the electrons orbiting the nucleus. So what's going on here? Let's have a look in more detail. First of all, our protons, electrons and neutrons, our pens, have charges. Protons are positively charged. We can give this a plus 1 sign. Pause the video here and see if you can guess the charges of electrons and neutrons. Use the clues at the bottom of the screen to help you. Well done for having a go. So electrons have opposite charges to protons, which are positive. Therefore, electrons are negative. And neutrons are neutral. They have no charge. Neutrons, neutral, no charge. We can give this a 0. Tricky one. Because they're matter, they also have mass. Matter has mass. Protons are a 1. Neutrons are the same. And electrons are so small, their mass is negligible, which means it is very tiny. They have a mass close to 0, but not totally. So for simplicity, we can say approximately 0. But the stuff around us is not made of the same stuff. We have different atoms, and these atoms are different to each other. Pause the video here and see if you can list some similarities and differences between a lithium atom and an oxygen atom. If you can't think of any more, try the challenge at the bottom of the screen. Let's see what you all thought of by starting with the similarities. First of all, they both have protons, electrons, and neutrons. They both have a nucleus. And they both have 2 electron shells around their nucleus. Good job if you got any of these correct. Despite looking similar, they do have some differences. If you look closely, they have a different number of protons, electrons, and neutrons. Lithium has 3 protons, oxygen has 8. Lithium has 3 electrons, oxygen has 8. Lithium has 3 neutrons, oxygen has 8. Good job, guys! Now, if you gave the challenge a go, you may have noticed that the number of protons is the same as the number of electrons in a single atom. For example, lithium has 3 protons and 3 electrons. Oxygen has 8 protons and 8 electrons. This makes atoms' overall charge neutral, 0. Wow, we've done a lot so far. Let's have a look at another difference between atoms, their shells, which is totally dependent on the number of electrons a single atom has. For example, you can see lithium has 3 electrons in total. It has 2 on the inside shell and 1 on the outside shell, also known as the valence shell. On the other hand, sodium has 11 electrons around its nucleus, 2 on the inside, 8 on the next shell, and 1 on the valence shell. Now I can hear you thinking, how are you supposed to know which atom has how many shells? Let me let you in on a little secret. We follow 2 rules, the inside-out rule and the 2-8-8 rule. In other words, we draw our atoms on starting from the inside and work our way out. The inner shell is the smallest, so therefore it can only hold a maximum of 2 electrons before it fills up, and you have to start a new shell. These shells can hold up to 8 electrons, and the same for the next shell. See? 2, 8, 8. But it is worth noting that not all of these shells will always be full. You just need to look at the information that's given to you. Let's look at some examples together. Lithium is a small atom. It only contains 3 protons in its nucleus. Therefore, it has 3 electrons. Remember, the number of protons equals the number of electrons in a single atom to make it neutral. Using our 2 rules, we place 2 out of our 3 electrons on the inside shell, and our remaining 1 on the outside. Remember, they will not always be full up to 8 at this point. You can check these by adding them up like so. Let's look at a larger atom, sodium. It has 11 protons, therefore it has 11 electrons. Working from the inside out, using the 2-8-8 rule, it has 2 electrons on the inside, 8 on the next. 2 plus 8 equals 10, which means we have 1 electron remaining to place. So we start a new shell for this 1. Remember, you can add them up and check. Time to pause and have a go at the examples below. Copy the shells onto a bit of paper and use the information below each one to fill in your electrons. If you need to, you can go back and replay what we've just gone through so you can hear it again. It's time to mark our work. Give yourselves a tick if you got it correct, or annotate your work so you know for next time. We've been told helium is an atom that has 2 electrons. We just need to add these 2 to the inside shell like so. Moving on to carbon, we've been told it has 6 electrons. Working from the inside out, we put 2 of these 6 on the inside shell and the remaining 4 on the outside. It doesn't matter where you draw your electrons on each shell, just as long as you have the correct number. Although pairing them up like this does make it easier to see and count them. Fluorine has 9 electrons, which will go 2, then 7. Remember, we can check by doing 2 plus 7, which comes to 9, so I know this is correct. And finally, aluminium. It's the biggest of these atoms with 13 electrons. Starting from the inside, we have 2 electrons. This shell is now full. So we start a new shell, which can hold a maximum of 8. At this point, we know we have 2 plus 8 electrons, which gives me a total of 10. I therefore have 3 left to place. So I start a new shell to add these remaining 3. I now have 13 electrons in total around my aluminium nucleus. Excellent stuff, guys. Let's round this up with a mini quiz to see what we have learnt this lesson. Question number 1. Atoms are made of protons, electrons, and neutrons. Give yourself a tick if you got this correct. If you didn't, remember atoms have pens. Question number 2. The charge of a proton is positive. Question number 3. True or false? Atoms are tiny, solid balls. This is false. Maybe once thought as solid balls, now we know they are mostly empty space. Question number 4. What are the 2 rules we follow when drawing electrons on shells? Inside out and 2, 8, 8 to fill the shells. Last but not least, draw a boron atom that has 5 electrons. You may need to take an extra minute for this question. Your atom should have 2 shells around a nucleus. The inner shell should have 2 electrons and the outer shell should have 3. Really great work, everyone. Now it's time to pause the video and rag your process. Red if you need more practice, and this is totally okay. Amber if you feel like you get it but need a little more practice. Or green if you now feel confident with atomic structure. Thank you so much for watching this video, guys. If you enjoyed it and would like to see more from Top Marks Science, you can like this video, subscribe to this channel, and we'll see you again next time. Have a great day.